Welcome to SIMcast, a podcast brought to you by the Society for Imaging Informatics and Medicine. This episode of SIMcast features the second of two conversations on the history of VNA. In this episode, hosts Prasanth and Mohannad continue the conversation with guests Greg Strowig, Ken Persons, and Brian Willaert. The group dives deeper into major milestones along the timeline of archive development, closely examining individual components and core services of a VNA. Greg currently serves as Vice President of R&D for Medical Informatics Product Development at Fujifilm Healthcare Americas Corporation. Ken serves as an enterprise imaging architect at Mayo Clinic in Rochester, Minnesota. Brian also works at Mayo Clinic, primarily as a team lead in the Mayo Image Management Systems IT team, recently moving into a role as the technology manager of the radiology department IT team. Sit back, relax, and enjoy this episode of SIMcast.
I was kind of wondering, what are some of the major milestones in the development of archives over this time frame that we're talking about?
So I'm going to take a start at that. And this is a comment I've been wanting to make along the way, and that's that VNAs are not all the same. If you were to lift the hood up to look under the hood to see what's there in the engine compartment, and you had 5 different cars, and each one of those, say, a VNA, they would look quite different. I mean, sure, they all have engines, and they all have windshield wiper washer fluid containers and the things that are common, but you'd find some odd-looking things and that some have and some don't. So what is that in terms of a VNA? Well, so some of the things VNAs do, and I'll just do a quick list here. These are other kinds of services. First of all, starting with support for all required DICOM object types and services. So if you crack open the DICOM standard, it is quite a standard. It's not just, I support DICOM. Do you support DICOM web, for example, or not? Do you support all the DICOM DIMSI type protocols or not? Do you support all DICOM object types? Do you support structured reports? Do you support, most VNAs are pretty good. That's like the engine in the engine compartment. They almost all support that. That's sort of a basic tenet. Now, as you move into some of the other functions and features, you'll start to see some differences. So I'll just rattle through a list here. Quality assurance and validation checking, looking at the images as they come in, making sure they're for the right patient, that they match against an order if there was an orders-based workflow, things like that as a service. Image availability notification services. So can the VNA tell another system that I've just stored an ophthalmology image for Ken? Because that system wants to know when they're available, or a dental image for Ken. And so the image availability notification services using standards is another piece. Receiving and processing imaging orders and updates. So can the VNA consume orders from, say, your EMR and updates to those orders and changes to those orders and process them? Managing of the images in logical groups. Brian did a nice job explaining how images from different departments might be logically managed so that it's an ophthalmology study versus a dental study versus a radiology study. And different systems in those departments may have different views because the ophthalmology department only wants to see ophthalmology stuff. They don't care about dental stuff. Can your VNA organize and process and manage the images inside it logically and present a virtual access to those images logically to users based on their role? So that's definitely a very unique feature of VNAs. Some can do that, some can't. Access to the data based on privileges, user privileges, another variation on that. EMR integration for orders-based and encounters-based workflow. I think, so we didn't really use the word yet, encounters-based workflow, but it's a very important concept. Greg was alluding to that as they went along, and VNA's beginning back in the year 2000, there was no concept of encounters-based imaging, but they ran into it headlong when they got into departments that didn't use orders, but took pictures and had to associate those pictures with the patient and some kind of an encounter that the patient was there for. So how do you do it? And the standards bodies themselves, hadn't, as I mentioned, provided ways to do that. So combination of DICOM and IHE integrating healthcare enterprise, which glues together standards to create standardized workflows, stepped up to the plate and helped with that while the vendors were dealing with how to do it. So I think this is important. It's a collaboration between the standards bodies, that's DICOM, IHE, the vendors, as they face customers that have needs and need to solve problems, some of which have standard solutions and some of which don't, working together to create standard solutions and evolve the solutions that are provided. And the customers themselves, the medical centers implementing stuff, have to be able to work together. So that sort of partnership across those three groups, I think, are very important. And the VNA has, if you cover the history of it, the evolution of the VNA and the evolution of the standards and the evolution of implementation of the VNA across enterprise imaging at medical centers is ripe with all kinds of examples of that. So image coercion services, big one here. So, when you think about image formats, they changed. You can compress, not compress. You can have big Indian, little Indian formats. You can retire formats. For example, ultrasound has a retired ultrasound object type and a newer object type. You can have all of those types of objects in those formats in your VNA, but your client might only be able to accept certain types. So the VNA can act as a broker to deliver the content in a form that you need it, whether that's the format of the images or the information in the images. Another great example is patient changes their name. So patient gets married, but they got 10 years of medical imaging in the archive in the VNA under their maiden name. How do you take care of, coercing in their new name so that for their current care that they associate it as the right patient? There's lots of examples of coercion, but VNA providing image coercion services in various forms is really critical. And the DICOM standard really addresses that well too. So working in a standards way, support for multiple patient IDs, cross-matching on searches, auditing and reporting for imaging studies that are stored and accessed, image transfer syntax transformations, and another big one, neutral storage. Greg alluded to this in the beginning. So neutral storage, we talk about vendor neutral archive, but there's also the idea of vendor neutral storage. As Greg described, and I remember in the 1990s, our first PACS, the storage that we had to it was glued to that solution. We tried to upgrade the storage a few years later to higher density disks, and we couldn't do it because you had to buy the storage through that vendor certified as part of the PACS. So VNA having neutral storage, meaning that you can change out the storage and not have to deal with the worry about whether that storage is certified for that product or whatever. And that's allowed us to evolve the storage into new formats like cloud-based solutions and new mechanisms to store stuff. And one comment I'll make around this, because I think this was a critical thought around the creation of VNA in the beginning, is a VNA is a data-centric model. It says we want to treat the data as data. We don't care what system made the data today and what format it created it in. We want the data around for a long time. We've always used 50 years as we don't know how long it's really going to be useful, but let's say 50 years, and that's a good number. And in that life, it's going to live certainly in very different homes, storage technologies that evolved that didn't exist 10 years ago or that are today. So you need to constantly be migrating that data as you retire storage frames and you evolve to new storage frames or new technologies. And the VNA is neutral in that respect, that it allow that to happen without the user feeling it, without the medical center saying, well, I can't get your images today because you know what, we're migrating all of that data to another storage array, so it won't be up till midnight tonight or something. So I think that's been a real key, is having neutral storage and sort of brokering the storage so that the user doesn't have to feel that. Effective dashboards and administration tools, patient merge services, support for non-DICOM images, image lifecycle management services. I'm going to stop with that. It's a big list, but the point being is that under that hood, you would find of a VNA, you would find many or all of these kind of functions, which really are enablers to workflows in the departments that generate and consume images. They are allowing that department to use the data, process the data in real time as part of workflows. So that goes back to what Brian said. The VNA is not just an archive. It's an active participant in the workflow that facilitates the steps that the VNA provides, facilitates that workflow in ways that make it effective for users. So I'll stop with that.
I'd like to add some more to that. Ken, one of your pieces in the engine or under the hood that you mentioned was the coercion functions, whether it's the actual image coercion or the DICOM header coercion. And that's really a piece that allows the VNA to work with any vended systems out there that the departments may be using. And so we have examples of, like on the image coercion side, there was a system that always wanted its images exactly back the way that it stored it. And so we were able to set up the VNA so that it never changed any of the values on the coercion going out to that system because it always wanted exactly what it stored. Other systems, they always wanted things like, most systems will want the patient ID, the patient name, like Ken mentioned, like with the maiden name, they'll want the name updated. So when we send it back, we'll coerce out that new patient name back to that system. On the image coercion side, on the outside of the DICOM headers, there's some systems that they always want the images as JPEG lossless 70, or they don't do ILE, or there's some transfer syntax that they don't support. And so the VNA is able to handle that. And so even if the images are all stored locally in the VNA as JPEG lossless 70, and this system that just came into the healthcare environment only wants ILE, the VNA can provide that image outbound, coerce it into ILE from JPEG lossless 70. And so then that system can get it in the format that it wants it. And then obviously update the DICOM header. We had examples of where one system wanted the patient ID with a leading 0 on the front. Most of them would want it with the leading 0 stripped off and just the numeric value. Some want dashes in the patient ID because that's how they've always handled the patient ID. And the VNA is able to set up coercion rules within the VNA to give this system the data that it wants it, the way it wants it, and this system tweak it so that it gets it back the way it wants it.
And I think over the history of the VNA, some interesting things for me came about. Ken mentioned information lifecycle management, or being able to manage the content in the VNA over time and according to specific rules that the institution set as a whole, or even by the department, or even by the image type. For instance, keeping mammography images for 50 years, maybe cardiology images for 10 years, and so on. And being able to move that data or compress that data over its life cycle to different devices and storage mechanisms. And it's funny because in the beginning of our sales as Terra Medica, we saw a lot of customers, a lot of commercial customers that were very concerned about the cost of their storage growth, interested in the fact that they could finally delete images. They could finally delete images if they got a VNA. And they could treat them differently, as I said, according to the modality or things about the patient study. And so that was a great relief to them because, for instance, their PACS might not allow deletion of content. But the interesting turnabout was that once we implemented that site, then people would look around and say, well, we don't have actually any rules as to what we can delete. And that involves a whole bunch of folks within the hospital system that are going to have to get together and determine what our retention should really be. Even though they had retention rules for physical film in the film room, and they would throw out or recycle their film according to a very rigid schedule. Now, once things were digital, people just kind of said, we don't have to touch it. But the PACS administrators and the IT folks were saying, yeah, let's delete this stuff. So in essence, what we found was people didn't delete it. They initially thought they would, but nobody could get the corporate governance and decision-making process to decide what the right retention periods were. And so that whole notion of people deleting data ended up not being of value. Now, what ended up being a value of our information lifecycle management functionality was actually being able to move that data between an old storage device to a new storage device automatically behind the scenes letting it migrate that data over time without impeding or impacting the users or the PACS systems that sat in front of the VNA. So people use the ILM functionality for that. Now, some 20 years later, people are actually congratulating themselves for never having deleted their data, because guess what? Now it's the world of machine learning and AI, and we need a great basis of information, great amount of clinical data over patients' lifetimes to make these algorithms get better and to develop those algorithms. And so now they have that data and they can use it as a basis for improving healthcare through those mechanisms. So it's interesting how the arc of just that one piece of functionality and what its initial thought and need was turned out to not be the end use. And now having that data around is actually of value to customers. I think another step along the way as we transitioned into enterprise imaging was when we had the VNA, there was a great understanding as to what it could provide, but it wasn't very easy to demonstrate. And when we're in a sales setting, it's not a very exciting thing to talk about if you can't demonstrate something. So that was a little difficult. And then people started to say, well, what can I do with all this data? Now it's in a common repository. Yeah, I know I can get it back on my PACS systems, but what can I do with it outside of that PACS system? And thus that created the need or the birth of what we'll call enterprise viewing, clinical viewing. Now, Mayo had their own homegrown clinical viewer that was on thousands of desktops, but that was not the norm outside of certain institutions. The norm was if you wanted to look at some images, you had to either walk to the department that created those images and look at them on a PACS workstation, or there might be a PACS workstation situated in your department, for instance, in ortho, so that you could walk over to it and use it. Or later, PACS vendors started including a web viewer for their particular images that could be connected to the EMR. And information lifecycle management and this viewing capability sort of ran into a clash with each other because customers were trying to drive down the cost of their storage by moving content to slow storage. But then clinical viewing became very important and very popular, and you couldn't predict what study a clinician was going to want to look at. Was it a study from yesterday? Or was it a study from 3 years ago or 13 years ago? And so that expectation of being able to immediately retrieve data and be able to view it, not like we have today in viewing, Netflix, was something that came about in the 2008, 2009 timeframe where people wanted that immediate access. And so moving content to the slowest possible storage, tape or what have you, became a problem because now you had to have it on something that was at least accessible in a reasonable time frame for these clinicians to start seeing the data. So enterprise imaging really kind of started around that time as the VNA brought an enterprise backbone for the repository of information, and the enterprise viewer came into vogue to be the way to see what's in the VNA or see across systems and bring the data to the masses, if you will. And then things have evolved since then, as we've talked about, through the incorporation of other specialties, other departments outside of the traditional radiology and cardiology departments.
Awesome. I guess the next question is, you've alluded to this with talking about enterprise imaging a lot, but looking more at historically, how has the VNA assisted the transition into enterprise imaging?
I'll start with that. So I think the VNA was one of the blessings that came out of it. Enterprise imaging was a term that evolved, I think 2010-ish, I don't know, 2008, 2015, in that range, the enterprise imaging term, somewhere in that range it came about, and there were lots of groups trying to decide what to do. And it was really this discovery of all this other imaging that had gone digital and they didn't have a place to store it, and coming up with a solution for that. So enterprise imaging there's some nice white papers that came out from SIM in the 2016, 17, 18 timeframe, or enterprise imaging work groups that developed. The VNA was sort of a gift because it was a standards-based thing. It really provided a lot of the core infrastructure that was needed for expanding the imaging services across the enterprise and taking and using the data in new ways. I think another thing Greg pointed out, and I'll echo, we didn't know how long we wanted to keep the data, and there was lots of concern about cost, and we argued about using ILM for a long time, but ended up keeping everything, and we're really glad we did. And now, as we've come out the other side of that, all of our imaging data is connected to VMR, the viewers, that we don't have this concept of not being able to find data and view it just in time if you want, or use it for AI. It's really fortunate. So I think the VNA was a key ingredient to enabler for enterprise imaging and something to build on top of for the workflows that needed to be established, to support enterprise imaging or in other ologies that didn't have more robust, well-defined workflows like Greg also described. So I think the VNA was a very important part. And also the other part that was been talked about a lot in this webcast is the ability of the VNA to organize the data, index it, organize it by logical groups, by department, manage the things about the patient, like their name changes and patient ID lookups. So those were all inherent parts of the VNA technology, which also benefited enterprise and other users of enterprise imaging. The last thing I'll say is that when you look at enterprise imaging from the other direction, what became evident is that across all the departments, there were a common set of services that all of them needed for enterprise imaging. And a few of the obvious ones are archival is an obvious one, viewing is an obvious one, but image exchange between medical centers, rather than having departments do that themselves. Each department burns the CDs and DVDs, has their own burners. That's really naturally a centralized service. AI type work now is starting to enter into that same realm. There really are a number of core services that make sense to provide at the IT enterprise level that service all departments, kind of like providing power in your house, right? Or, networking in your house. Those are core services that are used for lots of different things in the house. There are core services that are common to enterprise imaging across the departments, and the VNA provides a natural home for many of those core services to build on top of.
And the other piece is that the VNA level, which provides these core services to all imaging departments that generate imaging, especially the non-radiology, non-cardiologies, like the ophthalmologies or family med, or a lot of these departments that might just do some ultrasounds and need to be able to basically load those images from their ultrasounds, capture them, save them somewhere, and then have them be available in a clinical viewer. The VNA is able to provide kind of those core services to those smaller imaging departments that create some imaging, that don't have their own IT people, they don't have their own departmental system to manage within their department. The VNA provides those enterprise imaging services to those departments and allows them to get their imaging into those enterprise-wide clinical systems. Some of like anesthesiology, et cetera, they just need to be able to save their ultrasounds so that they can be billed for, things like that. It provides those types of areas with those core functions.
We even found the fact that having a centralized repository that has security and has proper backup, disaster recovery, all of those sort of IT needs enables the fact that departments like oncology, which have for a long time had non-standard proprietary treatment planning systems that create data in their own file format that nobody else could use, being able to put them into a repository like the VNA and have it indexed according to the patient allows that information to be shared much easier across physical locations than the customers used to have to do in the past, which often involved maybe a file share if they were lucky, but that created indexing issues, access control issues, auditing issues that wasn't evident as to how that was all managed. So being able to just be able to share across a backbone of an enterprise system was very important, even for proprietary data.
Okay, thank you. Again, I appreciate the level of detail. I love the fact that all of you are weighing in and giving your thoughts. I know all three of you kind of touched on this, but if you don't mind, maybe we can sort of try and tackle this more of like an enumerating style. So we've talked about a lot, the history of VNA, and I'm curious, between the three of you, what do you think the future might hold for VNAs? Obviously, we've talked a lot about enterprise imaging. That's a current trend, but anything else beyond that? Brian, maybe we could start with you.
So I think one of the areas specifically at Mayo that we see kind of coming that the VNA will be involved with more in the future. So one of them is obviously the move to the cloud. So today our VNA is definitely the servers that run the software, the VNA software are on-prem, the storage is all on-prem, but starting to look at supporting cloud-based, at least the storage levels, and then possibly even hosting the application in the cloud eventually. Those are definitely some pieces that are coming in the nearer future. Another piece is just as we look at other ologies that are bringing their images into the digital world. So pathology, as a large digital pathology project underway at Mayo, bringing basically all of that, what's always been on glass slides, bringing that into the digital world, being able to actually diagnose from the digital images versus having to have the slides under a microscope type of thing. And so that's blowing up, and that's a huge amount of imaging data, many terabytes of data that will be coming from that news source. And I know Ken probably has more comments on the pathology world.
Yeah, I guess as far as the future goes, I don't have any real additional comments on the pathology world, but I think that's a very interesting space, and we probably could have a whole separate webcast about that topic. I would recommend that actually. But, looking to the future, I guess, for VNA, I think that the concept has really supported us well for 20 years, and I don't see an end in sight. It is continuing to evolve. And I think the next phase of web services and seeing how those things mature and get actually translated into practice will be interesting. And I think the VNA is sitting in a good position to provide the basis for that. It certainly is a crosshairs where a lot of different vended solutions have to work together because it's an interoperability statement where working with web services, both ends have to function with web services efficiently for the systems to work. And I think we've spent a lot of years working with traditional DICOM DMC services, perfecting them, optimizing them, parallelizing them, and really have gotten to the point where we can deliver data very efficiently from the VNA type of services. I think one of the challenges probably we have for the future is looking, so the VNA as, again, and this is where the archive part does fit, is really an archive, although it's used for workflow, as we've mentioned over the course of this webcast, but real-time access for imaging through mobile devices, and using web services and getting the performance you need reliably, consistently, I think is one of the challenges, so that you can start using that data real time. So I'll give an example, and this I will go to digital pathology for. So pathology objects, whole slide images, are very large, in the order of several gigabytes per just one image. And DICOM has really nicely addressed a way to format that data so that you can interact with it in real time, just with the parts and pieces you need for just the resolution you need at just that moment through web services. And I think, so, creating viewers and solutions that can work with the back-end VNA through those web services and utilize some of those capabilities to move just the right amount of data, just where it needs, just when it's needed, is one of the challenges for the future. And I really see, interoperability pushing the performance limits of that, optimizing, the systems that work together through standards-based protocols and services to work in real time in mobile and remote environments, where the PACS nothing has to be local anymore. Everything is virtual. Images can be captured here, viewed there, interacted with in a third place, all in real time. And I think that is the future. And I think I see the standards moving in that direction too. So a good example is video. DICOM just created one of the newer standards around video to do, it's called real-time video, which can allow multiple real-time threads of video to work in synchronization with each other. So you can do things like remote surgeries where the cameras you're using, multiple cameras involved, are all synchronized down to the millisecond. I think our challenges are going to be moving into that next wave of capabilities that our whole world is evolving into around web services, cloud, real-time access to data through standards, and the VNA playing a core role in that.
I would add, I agree with what Brian and Ken said in terms of cloud and the evolution of medical imaging. It's not a static field. It continues to grow in diverse ways. So keeping up with the various standard evolutions and being able to serve up content where and when it's needed. I think as we move into the cloud, there's new opportunities to create essentially virtualized repositories of content that can be placed in various geographies to give fastest access to that content, but still operate as a single unified system, if you will, an enterprise VNA that maybe has multiple representations across geographies so that those geographies can access that data quickly and easily. This is important to healthcare in the United States and outside the United States, as in the US, there's more and more acquisitions and more growth of these health systems that cover not just local regionalized geographies, but perhaps even multi-region or nationwide coverage. And so being able to serve up that content across the country, no matter where you are, in the fastest possible way, or being able to store that content in the fastest possible way, is something that cloud technologies can enable. And I think in our case, our journey with the other specialties outside of the traditional DICOM specialties and going through more development of encounters-based workflow, I think that's a journey that's sort of never ending. These systems will evolve and change, perhaps slower over time, but the needs in these areas are great. And there's more and more content being generated every day outside of the traditional imaging departments. And lastly, I would say, just as the VNA has become an active participant in the clinical workflow of a healthcare system, I think we're going to see the VNA become an active participant in research and machine learning, artificial intelligence, algorithm development, and we're just at the start of that as well.
All right. Thanks once again to everybody. I think in the interest of time, we better start closing out here. So I just want to open it up to all three of you. If you have any other thoughts or comments of anything else you wanted to add, we'd love to hear those from you. And of course, again, we thank you for your time. Let's start with you, Ken.
Yeah, so I just would have one comment, and it's the underappreciated aspect of making sure it's appreciated. So VNA is a term, which we all know now, but it's really standards that have made it possible. It's a standards-based solution that's enabling the use of data interoperably. And I want to give a big pat on the back to DICOM and the bodies that have done the work over the years to create the standard and market the standard, get it out there, and the vendors that have adopted the standard, because sometimes it's not to their immediate benefit to do so, because it means that their products can compete more naturally with them. So I think it's really, I have to give a big pat on the back to the standards, and that's what a VNA is. It's a standards-based solution that's trying to solve problems and work collaboratively with medical centers, vendors, to implement and use those solutions to better patient care in the imaging space. So thank you to all the folks who may be listening on this that have been involved in helping with those standards along the way.
Well, I think, the history of VNA has been an interesting one for me over 20 some years, and seeing the genesis of the product category to the evolution of something we call enterprise imaging today. And I think, just as Ken spoke of standards and gave thanks to them, I would give thanks to our customers, not just of our own VNA product, but probably of all VNA products. Initially, it was probably a hard concept for many to understand, and certainly some, like Mayo, had a very good grasp of and vision of what they wanted to accomplish. But over the 20 some years that I've been with this company, with Fujifilm now, we have had a lot of long-standing customers who have seen their VNA evolve over time and have used us for 20 some years, which is an incredible length of time in the software world to see a system get used continuously. So certainly I give thanks to our customers. I think there's other VNA vendors that would probably do the same for their customers. We have appreciated the recognition that our customers have given us through class awards, and we continue to see a strong roadmap for the VNA product and product category. As we've talked about today in the history, there's a long road ahead and a lot of things we want to accomplish, some of which we know about today, some of which we don't know about because the future is hard to predict. So thank you.
Appreciate it. Last but not least, Brian.
Yeah, I was just going to mention, so on kind of the topic of VNA adoption within a health system, the VNA, one of the things it does is it does still allow each imaging department, it's not requiring them to move out of their best of class system that works best for their department. And so like radiology, they can still buy the best system, that their PAC system that works for their workflows. And cardiology can buy theirs that has their special echo and cath lab functionality. Ophthalmology can buy theirs and have their own departmental systems. And the VNA can work with each of those systems. Within those departments, they still have their choice of their best-in-class system that their physicians and their users want and need within their own departmental workflows. And that core function of the VNA is that it should be able to work with any of those systems as long as they follow those standards that Ken was saying that are so important. That if they pick those best-in-class systems for their department and they support DICOM, HL7, those standards, FIRE, that the VNA should be able to work with them and everybody can have the system that works best for them.
Excellent. Thank you so much. Once again, the three of you, appreciate your time. Thank you all very, very much. Appreciate it. Appreciate everything you've done to create this product class, maintain it, inspire it. And of course, for you, Ken, I wish you a very happy retirement.
Yeah.
Thanks
all right,
again.
thank you very much. It's been a pleasure. So good to see all you guys. Take care.
Thank you. Thank you to everyone.
Simcast has been brought to you by the Society of Imaging Informatics and Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.